For problem number 9 now, we need to determine whether this sequence, okay, has a sum. So does 49 plus 7 plus 1 plus 17 plus 149, dot, 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 keep going. Does this have a sum? And if so, what is it? And so let's just first write down what it means to find an infinite geometric series. So we have a formula, the sum of the first infinite terms, and that's our first term over 1 minus r, but that's given the following information, that the absolute value of r must be less than 1. And this is the point right here where it says determine. Determine whether this sequence, this series has a sum. This is how you determine. Because if your r is not less than 1, then you could stop and say it's not possible. And if it is less than 1, then it can, and I want to demonstrate why that works. So let's just first check this right here, okay? Is it true that this has an infinite, does this have a sum? Well, if we want to find r, it's easy, right? Just go ahead and take two terms and we divide them. So r equals our a sub 2 over a sub 1, which is 7 over 49, which is 1 over 7. And it's true that 1 over 7, the absolute value of 1 over 7 is 1 over 7. So 1 over 7 is less than 1. Therefore, yes, it's true. There is a sum. Now, so the second part, if so, find the sum. And that's when we're just going to plug it in right here. Okay? So our first term, a sub 1, is 49. So the sum of the infinite terms is 49 all over 1 minus our r. And our r is 1/7. Okay? Our calculator will generate this for us. And one of the main errors that Mr. Nzuz and I saw was you would do this, but then your answer was incorrect. And here's the big catcher with putting this into the calculator. Anytime that your numerator or your denominator has any plus or minus, the whole thing, either the whole denominator or the whole numerator, has to be put in its own separate parentheses. So if you were going to put this in your calculator, this is exactly what you would put. You would put 49. Okay, don't need any parentheses there because there's no plus or minus. And then you put divided by. See how there's a minus sign? So we have to put parentheses around the whole thing. So I'm going to do parenthesis 1 minus parenthesis 1 over 7 parenthesis. Check this out. This right here, this parenthesis is really right here, right? So since I had a minus sign, I have to put parentheses right here. Okay? So 1 minus 1/7. You do that right there, and that's going to give us our value. And get my calculator. And I think I just have the answer right here, so we'll just save us a little time there. So this is going to be 343 over 6. This is the precise answer. And we probably want to stay away from the decimal because we want the exact answer right there. So this is what you should get when you plug this in. Okay. So let me just talk right now real quick about what if our r was not less than 1. Okay, let's talk about this real quick here, and I think it's appropriate because the obvious question is, well, why does r have to be less than 1? And so let me give you a geometric sequence, and I'll give you a simple one. Okay, say if I had 2, and then 4, 8, 16, dot, dot, dot. Okay, and then if I said, this is arithmetic, right? Because, geometric, because 4 divided by 2 is 2, 8 divided by 4 is 2, so our r is 2, right? So notice that this r is not less than 1, right? R is not less than 1. And we're saying that it's not possible then. Well, why can't we find the sum of this using this formula? Check this out. See if this makes sense. Say if I use this formula here. My first term is 2. Okay, so 2 right here is my first term. All over 1 minus r. 1 minus r. Let's see here. 2 over negative 1. Does it make sense that 2 plus 4 plus 8 plus 16 plus 32 dot, dot, dot forever, does that all equal negative 2? You should be like, no, that doesn't make sense, right? So the reason that we say that it has to be less than 1, or okay, is because our sequence has to start from a big number and then it has to get smaller and 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 smaller, right? I mean, the sequence got to get so small, right, that it eventually becomes 0, and then you're just adding 0 every time. So that's the reason why that we say that our R has to be less than 1. And by the way, anytime that you take or you find a sum of an infinite geometric sequence, okay, always check R. Don't be surprised if we put a problem or so on there that we don't even say nothing and you just plug it in and you get some weird number but you don't even know. You need to plug in R to find out. You say, yes, I can do it because it's less than 1, or you say no because R is too big. And that's it right there.